phospholipid is the glycerol. Phospholipids. And they have, as their name suggests, a glycerol backbone. Very important molecule, glycerol. And has a fatty acyl group attached to it in a ester linkage. And these are just fatty acids. And there's another one in the 2 position here. Tends to be a little bit longer than in the 1 position, and we'll talk more about that. And then you have in the 1 position, you have a phosphate, which has a negative charge. And then there's a head group associated with the phosphate. And here you have sort of a diacyl glycerol component, and then this much of it is referred to as phosphatidic acid. I'm looking right at you. She won't look up. And then the entire group is known as, usually they're called phosphatidyl X, where X can be a proton, in which case you end up with phosphatidic acid. X can be, the most common one is choline, which has the structure the nitrogen has a positive charge here. And then another common one is phosphatidyl ethanolamine, which is very similar to choline. But it has an amine group here with positive charge. Phosphatidyl serine. This is ethanolamine. Ethanol, amine, just like it sounds. Here's the ethanol part here. And then serine. Phosphatidyl serine, in which case you have and then perhaps the most interesting one is inositol. And I've already mentioned alluded to phosphatidyl inositol before, where it's a 6-carbon sugar, and this is 1, 2, 3, 4, 5, 6, and you have OH groups. And we talked about PI3 kinase, phosphatidylinositol 3 kinase. Well, it phosphorylates phosphatidylinositol in the 3 position. And we'll talk more about that in a little bit. Now, typically, this R1 here is a saturated and is 16 to 18 carbons, and R2 is 16 to 20 carbons and is very commonly unsaturated. Now, the next major category of phospholipids is the sphingolipids. And they're derived from sphingosine. And these are interesting, and they have a, here's your X, and it's actually very similar to the glycerophospholipids. There's a nitrogen group here, though. And then now you have here this this NH3 plus here in this case, but what happens is that this is sphingosine. And it can form this amine group here can form a amide linkage and this amide linkage here, then you end up with, again, something that looks like, in the phospholipids, what does this look like? What does this look like? What would this be more less equivalent to? Diacylglycerol. It just has an OH group here. Now, this compound here is known as ceramide. And of course, it's a phospholipid usually, or it's derived from a phospholipid, so usually there's a phosphate here at and then here's your X group, and X is very commonly choline. And so choline, when you have a phosphoryl choline attached to the ceramide, you have what's known as sphingomyelin. Now, in the laboratory in 300, you're going to be doing something with recognizing carbohydrates on the surface of cells, and very commonly you attach carbohydrates to the to this O group right here. And they're known as they're common in the brain and galactocerebrosidase. You can tell I know a lot about this. But these, actually, these sphingolipids are interesting. They have some properties that distinguish them from the glycerophospholipids in that they tend, okay, emphasize tend, to have longer saturated acyl groups. Okay, now what is going to be the, what's going to happen with these more saturated acyl groups? What would be the tendency based on what you know, they're going to pack together. That's exactly right. They're going to pack. And, they have problems because we talked a little bit about it, we'll talk more about it, but membrane fluidity is a key component in membranes. And so when you have these packing sphingolipids, they're going to be less fluid. And that's exactly what happens. They tend to localize in what has come to be called a lipid raft. And they're rich in sphingolipids. And something we're going to talk about next is cholesterol, which in addition to its role in being precursors for steroid hormones and all kinds of interesting things like that, they are also very important components of every membrane in every cell in your body. So when people talk about cholesterol being bad for you, well, excess cholesterol is bad for you, but without cholesterol, you don't function. And so what these lipid rafts are is if this is you're looking down at a membrane, and you might find patches, and these patches tend to have some very interesting proteins on them. Like, for example, the epidermal growth factor receptor and other receptors that have tyrosine kinase activity. They tend to localize to these relatively insoluble lipid raft fractions. And so whereas a protein sitting out here in the membrane can move independently, this kind of moves as a group. And so it floats somewhat like a raft in a sea of more liquid lipids. Okay, so that brings us to cholesterol. And cholesterol has, most of you have some idea, it's a polycyclic aromatic compound